In this demo, we'll see how tenants can provide secured shared endpoints for the users for LLM inferencing in a serverless way. Let's first have a look at the conceptual view of the infra. So we have a management cluster where aarna CMS and PaaS is running, and then there are clusters with GPUs on which the tenant admin can deploy multiple models. These models can be exposed via unified secured endpoints. The users can create API keys which are created in the management clusters and are synced to the deployment cluster. The usage metrics of each of the users are synced from the deployment cluster to the management clusters. These metrics can be retrieved by the NCP billing system for billing purposes. The demo flow looks something like this. So there is an NCP admin who is responsible for onboarding the infra and also onboarding the tenants. The tenant admin will allocate the compute nodes, create the KRS cluster and the endpoint, and then deploys the model by specifying the rate limiting and pricing for that model. Tenant user will have the end user experience of accessing those models in a serverless way. For this demo, the infra is already imported and allocated by the tenant. We'll first log in as the NCP admin to get an overview of the current infrastructure which is onboarded. In the dashboard, we can see that there are two GPUs available and there is also a tenant which is onboarded. In the infra section, we can see that there are two compute nodes which are already allocated. Under the user management, we can see that there is a user with the role tenant admin, which belongs to tenant demo 1. We'll now log out of the current session and log back in as tenant admin. Upon logging in, we can observe that two bare metal servers have already been allocated by this tenant. Let's navigate into one of these bare metal servers to explore the observability dashboard. Under the GPU observability section, we have access to several key metrics, including the GPU utilization, power draw, temperature readings, etc. Now we'll go ahead and create a Kubernetes cluster. We will give it a name, an optional description, and then we will select a Kubernetes distribution from the available distributions and the corresponding version. We also choose to install NVIDIA GPU tools along with AI platform components, which are essential for bootstrapping the cluster to support LLM model deployment. For this demo, we will add a single worker node by selecting an available compute node and then proceed by clicking on allocate. The cluster creation and bootstrapping process will now begin. This may take a few minutes. We can track the status of the cluster, and once the cluster is up and running and the provisioning is complete, the cluster status will update to running. With the cluster up and running, let's move on to creating an inference endpoint. We navigate to the endpoint section and click on create new endpoint. Here we input the endpoint name and the optional description and the fully qualified domain name in the host name field. Ensure that a valid DNS record exists for this FQDN in your DNS provider. Then we'll select the cluster this endpoint will map to. For the TLS SSL configuration, we have three different options. CA signed, which automatically generates and applies a signed certificate, and then there is self-signed, which allows us to generate a self-signed certificate, and we also have an option to upload, which enables us to upload a pre-generated certificate and private key. We'll select CA signed and click create to finalize the endpoint setup. Finally, we'll go ahead and deploy an LLM model. Let's navigate to the model section. Here we can see all the available models which can be deployed. To initiate a deployment, click the deploy icon on the desired model card. Provide a name for your model deployment and proceed next. Now in this section, we select one of the available endpoints. We can see the endpoint which we just created in the previous step. We'll select that, and then we will select the GPU type and GPU count. Optionally, we can also enable auto scaling by defining the minimum and maximum replica count. So there are two auto scaling strategies to choose from. One is the hardware based auto scaling, which scales the nodes based on the resource usage metrics, and the other one is pending request based auto scaling, which scales the node based on the number of pending inference requests. Now we'll click next to proceed to the next screen. Here we can define the rate limits for the models based on tokens per minute as well as requests per minute, and also specify the pricing for the model. After filling those details, we will click on deploy, which will initiate the deployment of that model. Now we will look at the end user experience of consuming the deployed model in a serverless manner. For this demonstration, we will continue using the same tenant session, but in a real world scenario, tenant users will be the one who would be accessing these models. So we will click on the platform features button, which will open a link in a new tab. Here under the model section, we can see the model that was deployed earlier by the tenant admin. Before interacting with the model, we first need to generate an API key. This can be done from the settings section. Once the key is created, we can just copy the key and store it securely. It will only be displayed once. Now we will navigate to the model section again and open the model in the playground. Here in the playground, we can interact with the model via a chat-like UI, entering prompts and receiving the streaming response in real time. The inference also allowed us to fine-tune various parameters by adjusting parameters like maximum token, temperature, etc. To check the usage, we can navigate to the billing section. In this section, we can see the insights to the token usage, including input and output token per model. In addition to the playground UI, models can also be accessed programmatically. The endpoints are fully compatible with the OpenAI API specification, allowing seamless integration with existing tooling. For example, we can also use a simple curl command to query the model. Make sure to include the generated API key in the authorization header. Now, again, here in the billing section, we can see the increment in the tokens processed. This wraps up our demo. Thank you.